And do not make the same mistakes. Some of the very most basic things, you must have your axis labeled, x and y for all of them. You must have your equation of line. You must show me your intercepts, if any. So all these must be shown. Now, for part D, I hear a lot of murmuring. I did not receive a single piece of work that was perfect. So all of you should be focusing on doing your corrections, on noting the points right now. For 4D, I find it hard to imagine how you will know that the graph looks like this if you did not show the working for y equals to 0.25 power negative x. So I expect to see working over here to show that actually it is y equals to a constant with a positive power for x, where the constant is greater than 1. Now for all of these exponential graphs, we see that the graph goes nearer and nearer to the x-axis, but it doesn't touch. So this is a common mistake that I see for graphs. Okay, for the first one, y equals to 5 power x. Okay, this being 1. Does it show that the graph goes nearer and nearer to the x-axis in this case? It looks like it stopped abruptly over here, right? So I expect it to continue. I expect it to continue, go nearer and nearer and nearer. Of course, draw it properly, and therefore your graph should look like this. Similarly, when we have the graph of y equals to 1 over 6 power x, this is what I saw in many of your work. Okay, you draw your x and y axis. Wow, x-axis very long, very good. Then your graph looks like this. What nonsense is this? How does it show that the graph goes nearer and nearer to x? If you extrapolate, you continue drawing, wouldn't this graph look like this? So draw it properly. It is supposed to go nearer and nearer without touching. So if you do something like this, take an eraser, erase the bottom bit, and edit accordingly. Okay, it goes nearer and nearer without touching. Alright? Your logarithm graphs as well. It is actually just a mirror image of your exponential graphs along the line y equals to x, which you will need to include later on. Okay? So over here, we see that the graph goes nearer and nearer to the y-axis without actually touching it. So look at this part. It is supposed to go nearer and nearer. If it is not obvious enough, let me adjust my y-axis. Now does it look like it's going nearer and nearer? Yeah, that is how you adjust it. And when you draw the x and y axis, use a ruler. This is another one. Question 2a. They are symmetrical about the line, about the y-axis. Some of you are just telling me they are symmetrical. Symmetrical about what? Yes, about the y-axis. So in this case, I've got two curves. You notice that I show that it goes closer and closer to the x-axis in both cases. Don't just stop abruptly. Question 3, part 1. I've shown you the solution for this already. However, I see work that looks like this. Okay, so you give me a curve, you give me a straight line. By the way, all your intercepts must be shown. You give me a curve, you give me a straight line. Then they ask you for the number of solutions. Based on the graph, how many intersection points do you see? How many do you see? 1 or 2? The graph only shows 1, right? So what are you expected to do? Remember, both graphs, they are supposed to extend all the way to infinity. you cannot just have a graph that stops here. Then what happens before this value? You mean the graph just stops like this? No, it cannot be. It must continue. So you extend it, you extrapolate it, and you see that, hey, definitely will cut another point over here. That is how we get two solutions. Number of solutions, 2. And question 6. Question 6, sketch the graph of y equals to ln x. So I like to sketch the curve first before I sketch the axis, so that I'm not bounded by the scale. Okay, so this is the shape of a y equals to log x, y equal to ln x graph. So it is supposed to go nearer and nearer to my y-axis. So this being my y-axis, it is supposed to cut my x-axis at the value 1. So this over here, x equals to 1. Y equals to ln x. The next part, in order to solve the equation, e to the power of ex equals to x e to the power of 4, we need to sketch a suitable straight line graph. And I know that I must extract ln x out from the equation given to me. It is not there yet. Obviously, we need to take ln on both sides. Ln e to the power of ex equals to ln x e4. Here we have e to the power ex ln e, which I know this will give me 1, equals to ln x plus ln e power 4. Now I see my ln x appearing already. Continue to simplify. Ex equals to ln x plus 4. Because the power is brought down. Over here, ln e is just 1. So I get 4 times 1. Continue to make ln x the subject. Ln x equals to ex minus 4. I already have the yellow graph. Now, all I require is to answer the question in part 2. I need to find the equation of straight line. Equation of straight line is y equals to ex minus 4. Okay, why? Why must I sketch this graph? Because I already have the graph of y equals to ln x, right? That's the yellow one. So in order to solve a simultaneous equation, I need to do substitution, which is what I'm going to be doing over here. So this is my other graph. It is known as y equals to ex minus 4. Solving them simultaneously using a graph will result in intersection points, and the intersection points will tell us the number of solutions. So the graph y equals to ex minus 4. I know the gradient is positive. The value is e. So it must slope upwards. Intersection point, y-intercept, equals to negative 4. So it must start from here, negative 4. It must go upwards. A straight line up. So this is my graph of y equals to ex minus 4. These are the two graphs to sketch. Now how many solutions do you see? 2 points of intersection. One over here and one over here. So when I solve the green and yellow equations simultaneously, I get 2 solutions. I don't get how you can give me the answer as 2 when your graph only shows 1 intersection point. Now quick check. graph A and graph B. How many solutions are there? Okay, 2 is correct. Graph A and graph B, how many solutions? Graph A and graph B, how many solutions? Good. Graph A and B, how many solutions? Easy, right? Last time when you learn your simultaneous equations, all straight lines only. How many solutions? Yeah, 1 only. Then if I have 2 sets of parallel lines, how many solutions? 0. If I have the same straight line, how many solutions? Infinite. Okay, but this case rarely tested lah. So I hope this clarifies any doubt